All right, in this video, we are going to go over lesson 4-2, add rational numbers. So some important vocabulary that we're going to be using in this lesson is additive inverse. We also use additive inverse in module 3 in operations with integers, and we're also going to use it in this module with operations with rational numbers. So an additive inverse is two integers that are opposites. The sum of an integer in its additive inverse is 0. Another key vocabulary we're going to use is the word opposite. Okay? An opposite is two integers are opposites if they are represented on a number line by points that are the same distance from 0, but on opposite sides of 0. The sum of two opposites is 0. All right, we're going to start with our notes. Feel free to pause and rewind this video as needed, so that way you can get the notes down, or if you need to rehear something or have something explained once again. So again, we're going to 4-2 add rational numbers, and the clear target is I can add rational numbers by using the additive inverse and the rules of addition. So let's look at the first example. The first example is asking us to find the additive inverse. So remember, the additive inverse is going to be two integers that are opposites. And opposites are integers or numbers that are represented on two opposite sides of the number line, and they're the same distance from 0. So if we wanted to find the additive inverse of -7/8, we can make this line a number line. We can make this 0. And I'm going to split each of these sections into eighths, since our denominator in our fraction is eighths. So all the way to the right, I have 1. All the way to the left, I have -1. So I'm going to split this into 8 sections. Okay, now first I'm going to graph -7/8. So -8/8 is equivalent to -1, so -7/8 is 1/8 less. So this is -7/8, and you can just count 1/8, -1/8, -2/8, -3/8, -4/8, -5/8, -6/8, -7/8. So that's going to be this here. Okay. Now, in order to find the additive inverse or the opposite, instead of going from the left, going left from 0, I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7. And that's going to be +7/8. So the additive inverse is going to be a +7/8. All right, example number 2, we are finding the additive inverses again. And it says Annalise earned $36.82 at her part-time job, and she earned $18.50 babysitting. Find the total amount she earned, the additive inverse, and describe a situation so that Annalise ends the week with $0. So let's first find the total amount that she earned. The word total means that we need to add. And we want to know how much she earned. So we know from her part-time job, she earned $36.82. And this keyword here, and I'm going to put a plus sign. It says here that she earned $18.50 babysitting. So I'm going to add $18.50. It's going to give us the total amount of money she earned. When we add these two together, she earned a total of $55.32. You can say Annalise earned the next thing it asks us is to find the additive inverse. So remember, the additive inverse is going to be the opposite. The opposite is represented on the number line by points that are the same distance away from zero, but on opposite sides of zero. So $55.32 is on the right side of zero. We need it to be, the additive inverse or the opposite will be on the left side of zero. So that would be negative instead of positive. So the additive inverse of $55.32 is negative $55.32. The last part of the question says, describe a situation so that Annalise ends the week with $0. So now we want to just write something in context of the problem. So it says Annalise earned $36.82 from her part-time job and she earned $18.50 babysitting. So we know in total Annalise earned $55.32. If she wants to end with $0, then we're going to have to use that additive inverse of negative $55.32 and take it away. So something in real world context of this problem that could mean taking away, she could have lost $55.32 by maybe it fell out of her purse. She could have donated $55.32 to a good cause. Or maybe she went to the store and spent $55.32. All of these are scenarios that would represent negative $55.32. And if she earned $55.32 and then spent it or had a negative amount of $55.32, that would be additive inverse. So for this scenario, I'm going to say that after she earned the money, I'm going to say Annalise, after earning $55.32, Annalise donated $55.32 to Teacher Appreciation Week. The word earning is her positive and the word donating is her negative. And remember, those opposites make zero. Example 3, we are going. So for example 3, we're going to add rational numbers, and we want to find negative 3 and 5/9 plus 1 and 2/9. We want to write it in simplest form. So when I look at this, the first thing I see that this is a mixed number. I'm going to convert it to an improper fraction. In order to go from a mixed number to an improper fraction, you need to take your denominator, multiply it by your whole number, and then add your numerator. So 9 times 3 is 27, and 27 plus 5 is 32. So I'm going to rewrite negative 3 and 5/9 as negative 32/9. Remember, you keep your denominator. Plus 9 times 1 is 9, plus 2 is 11. So this is going to be plus 11/9. And here I converted my mixed number to an improper fraction. Next, I want to be able to predict, is my sum going to be positive or negative? When I look at these two rational numbers, my first fraction is negative 32/9, and my second fraction is 11/9. Okay? 32/9 is the absolute value of 32/9 is of negative 32/9, is greater than the absolute value of 11/9, which means that you can predict that your sum is going to be negative. Okay? Anytime you are adding integers with different signs, so you can write this over here on the side. Anytime you're adding integers or rational numbers, it's the same rules as when we used integers, but now we're using rational numbers. So anytime you're adding irrational numbers with different signs, you're going to subtract the numbers and then keep the sign of the number with the greatest absolute value. So here, I am going to subtract 32 minus 11. 32 minus 11 is 21. So I have 21/9. And because the absolute value of negative 32/9 is greater than the absolute value of 11/9, then I'm going to keep this negative. Now, I want to write this in simplest form. So before I do that, I'm going to write on the side here that I subtracted 32 minus 11. And remember, the reason I did that is because these two rational numbers have different signs. And when you're adding rational numbers with different signs, you want to subtract the absolute value of the numbers and keep the sign of the number with the greatest absolute value. Next, I want to make sure that my numerator and my denominator do not have a greatest common factor. So 21 and 9 are both multiples, are both are multiples of 3. So I can divide the both of them by 3. 21 divided by 3, 7. 9 divided by 3 is 3. Notice how I'm keeping the negative here. And I divided the numerator and denominator by the greatest common factor, 3. Now that I have negative 7/3, that is simplified. So in order to write your answer, you can write your answer as as an improper fraction, which is negative 7/3. Or you can write it as a mixed number. To write it as a mixed number, 3 goes into 7 2 times. I'm going to keep my negative. And then 2 times 3 is 6. And so you're left with just 1 to get to 7. So it's negative 2 and 1 6. I'm sorry, not 1 6. 1/3. You always keep the denominator. Okay, so just to reiterate, I have the expression negative 3 and 5/9 plus 1 and 2/9, and I want to write it in simplest form. In order to do that, the first thing I did was converted my mixed numbers to improper fractions. And to do that, I multiplied the denominator by the whole number and added the numerator and kept the denominator. Then I noticed here I am adding rational numbers with different signs. You use the same rules when you were adding integers with different signs. So I subtracted the absolute value of the two rational numbers. 32 minus 11 gave me 21, and I kept that negative because the absolute value of negative 32/9 is greater than the absolute value of 11/9. Now, once I've done that, I still need to simplify. So in order to simplify, I check to see what is the greatest common factor between 21 and 9. The greatest common factor between 21 and 9 is 3. So I divided the numerator negative 21, and the denominator 9 by 3. So negative 21 divided by 3 is negative 7. 9 divided by 3 is 3. Now when I look at negative 7/3, the greatest common factor between negative 7 and 3 is 1. So since there's no greatest common factor greater than 1, that is as simplified as it can get. So my sum is negative 7/3, or you can take this improper fraction, convert it to a mixed number by dividing 7 divided by 3. 3 goes into 7 2 times, and then you're left with 1. So I got negative 2 and 1/3. All right, example number 4, we're going to add rational numbers. So we're going to find 1 3/4 plus negative 1/6. And we want to write it in simplest form. So the first thing we want to do is we want to convert these mixed numbers into improper fractions. In order to do that, we need to take each denominator, multiply it by the whole number, then add the numerator. So 4 times 1 is equal to 4, plus 3 is 7. So this is going to be 7, and we're going to keep our denominator of 4. So 1 3/4 as a mixed number is equivalent to writing 7/4. Plus, we're going to convert, we don't need to convert negative 1/6. So we have plus negative 1/6. Now, once we've done that, I'm going to write on the side here, convert mixed number to improper fraction. All right, the next thing that we need to do is we need to find the least common denominator, because we cannot add fractions with unlike denominators. So to find the least common denominator of 4 and 6, it's going to be 12. And the way that you do that is you find the least common multiple. So to find the least common multiple, you just find the multiples of 4. So the multiples of 4 is 4, 8, 12, 16, and then you keep going. And then the multiples of 6 is 6, 12, 18, and then you keep going. So I can write that out here on the side. LCM is your least common multiple. And you want to write out the multiples of the numbers that you have in order to find which one is the least. So for 4, we have 4, 8, 12, 16, 20, 24. And then for 6, we have 6, 12, 18. And I'm going to stop there just because I see that the both of them already have 12. So that's how I know that my least common multiple is 12. So since my least common multiple is 12, I am going to multiply each one of my fractions so that they have the denominator 12. So in order to make my denominator 4 a 12, I have to multiply by 3. So whatever I'm going to do it down here. I have to multiply 4 by 3 in order to make that denominator 12. Whatever I do to the denominator, I also have to do to the numerator. So 7 times 3 is 21. 4 times 3 is 12. So I can rewrite 7/4 as 21/12. Now I'm going to do the same exact thing for negative 1/6. So for negative 1/6, in order to make my denominator 12, I have to multiply 6 by 2. But if I multiply my denominator 6 by 2, I'm going to have to also multiply my numerator by 2. I'm going to keep my negative. 1 times 2 is 2. 6 times 2 is 12. These are still equivalent fractions. We're just writing them with the same denominator so that way we can add them together. So here I'm going to write that I rewrote fractions using the least common denominator. And to find the least common denominator, you use your least common multiple. Okay. So I'm going to rewrite this now as 21/12 plus negative 2/12. Now I can add these integers. When I look at these integers, okay, they have different rational numbers. When I look at these rational numbers, they have different signs, which means I can subtract the absolute value of the numerators and keep the sign of the fraction that has the greater absolute value. So here I can take 21, subtract 2, and I know I'm keeping my denominator of 12. So 21 minus 2 is going to give me 19. I'm going to keep my denominator of 12. Here I'm going to subtract absolute value of fractions. I know that in example 3 I showed this a different way, and that's okay if you like that way better. I'm just showing you another way that you could write it out or explain if you'd like. So here I subtracted. Okay. Now, when I look at 19 and 12, 19 and 12, I want to make sure it's in simplest form. 19 and 12 do not have a factor in common other than 1. So that is as simplified as it can get. So I can write it as 19/12, or I can convert it into a mixed number by dividing. So I will take 19 and divide it by 12. 12 goes into 19 one time. 12 minus 19 is 7. So I have a remainder of 7. I'm going to keep my denominator of 12. Last but not least, we have example 5. We're going to find negative 2/5 plus 2 3/10. So with this, you can do one or two things. You either have to write both rational numbers as decimals, or you have to write both rational numbers as fractions. You cannot combine them like this. So the first way that I'm going to do this is I am going to rewrite these as decimals. Okay, so to rewrite negative 2/5 as a decimal, we know that it's going to be negative. And to rewrite a fraction as a decimal, you need to use long division. So 2 is going to be my dividend. 5 is going to be my divisor. So I'm going to divide over here on the left-hand side. So I have 2 divided by 5. 5 goes into 2 0 times. 5 times 0 is 0. 2 minus 0 is 2. Since I have a remainder and I'm converting to a decimal, I'm going to add a decimal point, add a 0, bring that 0 down, and I'm going to start dividing again. 20 divided by 5, or 5 goes into 20, 4 times. 5 times 4 is 20. 20 minus 20 is 0. Now, even though I have a remainder of 0, this is a terminating decimal because it's going to the quotient will constantly repeat in zeros. Okay, so we can stop here since we got a remainder of 0. We do not need to keep going. So negative 2/5, the equivalent decimal of that is going to be negative 4/10 plus 2/3. Now, and here I just rewrite negative 2/5 as decimal, just so you know the steps that I used. Now when I look at these, I can predict that my sum is going to be positive. Because these two rational numbers have different signs, negative 4/10 and a positive 2/3, I'm going to need to subtract the absolute value of the two numbers, and then I'm going to keep the sign of the number that has the greatest absolute value. So 2/3 minus 4/10 is 1 9/10. The absolute value of negative 4/10 is 4/10, and the absolute value of 2/3 is 2/3. The absolute value of 2/3 is greater than the absolute value of negative 4/10, which means my sum is going to be positive. You can write it here as 1/9. That's going to be how you do this as a decimal. So in order to do this as a fraction, okay, the first thing that you are going to need to do is you are going to need to rewrite this. This is as a decimal. Now I'm going to do fraction. First thing you're going to need to do is you're going to need to convert 2 3/10 into a fraction. So it's important to use place value, so that way when you are reading decimals, you are able to convert it to a fraction. So this is 2 3/10. Now once I do this, now we're just going to use the same methods that we use in example 3 and 4. So I'm going to, I'll right here, rewrite 2/3 as a fraction. Now I'm going to convert 2 3/10 to an improper fraction. So I'm going to leave negative 2/5 plus, to convert this 2 3/10 mixed number to an improper fraction, I'm going to take my denominator 10, multiply it by my whole number 2, that's 20, and then add my numerator 3. So that's 23 tenths. Always keep your denominator. So here, I'm going to write, I convert 2 3/10 to an improper fraction. Now, what I need to do is I need to make, the only way I can add these is if they have the same denominator. So the least common multiple between 5 and 10 is 10. So luckily enough, I do not need to change this 23 tenths. However, I do need to change -2/5 into an equivalent fraction that has the denominator of 10. So I'm going to do this on the side. I have -2/5. And in order to make my denominator 10, I have to multiply 5 by 2. So if I multiply 5 by 2, then I also have to multiply my numerator by 2. -2 times 2, -4. So -2/5 is the same as writing -4/10 plus 23/10. So I'm going to rewrite -2/5 using my least common denominator. Now I'm going to add once again. So I have two rational numbers. We're going to use the same rules that we use with integers. Okay. Since these two rational numbers have different signs, -4/10 and a +23/10, then we need to subtract the absolute value of the numbers and then keep the sign of the number with the greatest absolute value. So 23 minus 4 is going to give me 19. I'm going to keep my denominator of 10. And right here, subtract 23 minus 4. Then, since the absolute value of 23/10 is 23/10, and the absolute value of -4/10 is 4/10, and the absolute value of -23/10 is greater than the absolute value of -4/10, then our answer is going to be, our sum is going to be positive. So we can write our answer here as 19/10, or we can write it as a mixed number. And to write it as a mixed number, all you really need to do is divide. I know I've been doing it just by talking, but I want to show you here on the side how you can actually do this. So you have 19. You have 19, and you want to divide by 10. 10 cannot go into 1. However, 10 can go into 19 one time. 10 times 1 is 10. 19 minus 10 is 9. Since I have a remainder and I want to convert to a decimal, not converting to a decimal, keeping it as a fraction. Since you have a remainder here, your remainder becomes your numerator and your divisor is your denominator. So that would be 1 9/10. And you can tell that these are the same. If you read this decimal 1 9/10, you read the same thing in this mixed number, 1 9/10. So it's important to read the decimals correctly. Thank you so much for watching this video. And if you need to rewind or anything like that, feel free to do so.